Rationalization of set. And this one, it says the process of removing static denominator to make it rational. Yes. So you have a fraction, but the denominator is a set. You have to rationalize it. So you have to remove the static denominator. That's why you have to rationalize it. So with this one, a out of root b, we are going to use the root b to multiply the numerator of the a and the denominator of the root b. Okay. So a out of root b, then the numerator is a root b. So a out of root b times root b out of root b. So this is what I'm saying, right? Good. So we are using the static denominator to multiply the numerator and the denominator of the question. So let's multiply. A times root b, we said earlier, is a root b. Then root b times root b is what? Root b all squared. That's what we said. Right? Good. Now, a times root b, the same thing. Now, root b all squared is what? We said that the root is half, so the square will cancel. So the answer is b. So our final answer is a root b out of b. Good. So this is what we are going to do under rationalization of set. So let's solve this. 1 out of root 5. So we use the denominator to multiply. This is what we are doing. So therefore, 1 times root 5 is root 5. Then root 5 times root 5 is what? Root 5 all square. Yes. Then our final answer is root 5 out of 5. So we have made the denominator rational. That's why it's the process of removing static denominator to make it rational. Yes. Please don't jump the step in order for you to get your method. 2 root 3. That one to the same thing. So we use the root 3 to multiply the numerator and the denominator of the question. Yes. So our final answer will be 2 root 3 times root 3 all square. Therefore, our final answer is 2 root 3 times 3. Then, our next example is 2 root 2 times root 3. Yes, we can rationalize it because the denominator is a set. Okay. So, let's use the root 3 to multiply through. Now, we said that 2 root 2 times root 3 is 2 root 6. Yeah, we said earlier under multiplication of set. Okay, then our final answer is root 3 all square. So that our final answer will be 2 root 6 over 3. This rationalization of set. Let's another example under it. How to rationalize a set. Simplify the following. This is our question. 5 out of root 2 minus root 8 out of 8. This one we can go straight to make the LCM by, since we know rationalization, let's first rationalize the 5 out of root 2 so that we can then continue, because the denominator is a set. That's why we said that we have to rationalize it. So 5 root 2, this is what we get. Solution. Right? This is the question, right? So you will get, if rational 5 root 2, this is how you rationalize it. Then the next one, continue. We can break the root 8 down. Yes, reduction of set, which I've said it earlier. Go and revise. So root 8 is 4 times 2. Okay. Therefore, if multiply 5 times root 2, we get 5 root 2. Then root 2 times root 2 is root 2 all square. That's why we got the 2 here. Good. Therefore, it's minus 2 root 2 out of 8. Then with here, what should we do? In the basic school, we know how to find the LCM. We were doing 1 out of 2 minus 2 out of 3. And we are doing something here. This was waiting for you in here. So 5 root 2 out of 2 minus 2 root 2 out of 8. So it will cancel. That's why we got root 2 out of 4. The 2 will cancel the 8. It can reduce. Okay. That's why we got root 4. 2 out of 4. So let's find the LCM here. Our LCM here is what? 4. Okay. 2 and 4. It's 4. We know how to do this in the basic school. 2 goes to 4 how many times? 2. Then we use the 2 to multiply the top one. So 2 times 5 root 2 is what? 10 root 2. Then 4 goes to itself 1. So we use the 1 to multiply the root 2. So we get negative root 2. Since the roots are the same, we can simplify further. So therefore, our final answer is 9 root 4. 9 root 2 out of 4. Because the roots are the same. So our final answer is 9 root 2 out of 4. We want to find m. That's it. So therefore, our m is 9 out of 4. That's how rationalize a set. Please solve more example under this. Subscribe to Senior Pelis, my YouTube channel, for more videos. Conjugate of set. We are done with rationalization of set, and we know how to rationalize. That's one is monomial. The denominator was monomial. It's only one. But with the conjugate, yeah, the denominator will be 2 in 2 terms. That's all. Binomial. Okay. So it's same as how to rationalize, but there's little change. So with the conjugate of set, if A plus root B represent a set quality, then A minus root B is known as its conjugate set, vice versa. So A plus root B, then its conjugate will be what? A minus root B. Okay, so it's the sign that will change here. So A plus root B, the sign will change to A minus root B. So if A minus root B, it will be A plus root B. That's the conjugate of set. The product of a set, its conjugate is a rational number. Okay, so the product of set, its conjugate is a rational number. So we make the denominator a rational number. That's what we are talking about. So that is A plus root B times A minus root B. So this is a conjugate. So we are using A plus root B times A minus root B. And this one we did under multiplication of what? Set. Right? So I said this one is what? Different of 2 squared. Do you remember? Yes. So the denominator is always different of 2 squares. So if we simplify this, if we use the A times A squared, you will get this. And you see that the negative A root B plus A root B will cancel. Then this is what? A squared would be all square. That's why I said that this one is different of 2 square. Okay, so always we conjugate, the denominator is different of 2 square. So let's try this. Yes, you see that this one is different of 2 square. So we just square it and then we subtract it. Okay, different of 2 square. Please always the middle sign is negative, not positive for different of 2 square. Remember, note that. So therefore, this is our final answer. That's for the conjugate of set. So let's solve some example under conjugate of set. Conjugate of set. Let's solve some example. So this is our first example here. 2 out of 1 plus root 2. And we are seeing this one is the same as the rationalization of set, but there's little difference here. Here the sign will change because it's binomial. So we take the conjugate. That's all. We use the denominator to multiply the numerator in the numerator of the question, but the sign between them will change. That's why we call it conjugate. Okay. So this is what we are saying. The denominator 1 plus root 3, the sign will change. So it's 1 minus root 3 times the numerator of the question and the denominator of the question. So 1 minus root 3. This is what I'm saying. Therefore, 2 times 1 minus root 3 and then 1 plus root 3 times this. And we're saying that always with the taking the conjugate of the set, the denominator is always different of 2 square. So this one, if you multiply it, this is what you get. Yes, you see, your final answer, 2 times 1 root 3 out of 1 minus 3, because the negative root 3 plus root 3 will go to 0, right? That's why we always say that it's different of 2 square. As time goes on, you will know. Therefore, this is our final answer. But that's not our final answer. We can still simplify this, okay? So 2 out of negative 2 minus 2 with 3 out of negative 2. So you can simplify this. Therefore, our answer is negative 1 with 3, because 2 goes into 2. So negative 1, then the 2 will cancel. Cancellation will go here. Basic algebra. Question 2. The same thing. 1 out of 3 minus root 5. So we take the conjugate. Therefore, what should we do? We said that you multiply the denominator, like the binomial of the numerator and the denominator of the question. But here is binomial, the sign will change. So we take the conjugate of it. So this is what I was saying. Then we will multiply the top and multiply the down. And I said that always, and taking the conjugate of a set, the denominator is always different of 2 squared. So this is what I was saying. So you see that the denominator is 3 to the power 2 square minus 5 root 5 to the power 2 or square. This is what? Different of 2 squares. Okay? So always, it's not by force to multiply it. You can just take the difference of 2 square, then you are good to go. So therefore, the square of 3 is what? 9, the denominator I'm talking about, and the root 5 all square is 5. So 3 plus 5, 3 plus root 5 out of 9 minus 5. Therefore, our final answer is 3 plus root 5 out of 4. We can still simplify further. This is the final answer. Good. So as easy as that. Let's continue with another example under conjugate of said. Our third example is this. So with this one too, the same concept. Let's take the conjugate of it. Remember, the sign will change as conjugate. Okay? Then we say that always the denominator, after taking the conjugate, is always different of 2 squared. So here, the denominator will be what? Root 3 all square minus what? Root 2 all square. Good. Yes. Therefore, we know what to do. And note that root 3 all square is the same as 3. Yes, because the 2 cancel the square roots as half. Good. Then, therefore, our final answer is this. Let's try with another example here. So this one, 5 out of 3 plus root 2 minus 2 out of 3 minus root 2. What should we do? Here, some will say that they will take 5 out of 3 plus root 2. They will take its conjugate. Then an answer they will get, they put it down. Then they come back and do the same thing for the answer they get. Then they subtract. That's another method. But please be careful. Here we can go straight to use the LCM. Yes, the LCM. Okay. In the basic school, like I said, we were doing 1 out of 2 minus 1 out of 3, and we were finding the LCM. Yes, this was waiting for us. You are happy there. You have to be happy. This was waiting for us. The same concept here. So here our LCM will be 3 plus root 2 times 3 minus root 2. Okay, that's our LCM. So the denominators here will be our LCM. This is our line. This, and I said our LCM will be this. Yes. Good. Now, 3 plus root 2 times 3 minus root 2 divided by 3 plus root 2. So this will go into here. The 3 plus root 2 will cancel the 3 plus root 2. So it will left with this 3 plus root 2 will cancel this. Okay. So it will left it only this. So we use this to multiply the 5. That's what we are doing at the basic school. So this will cancel this. It left with this. Then we use this to multiply the 5. So 5 times this. Yes. Now, 3 minus root 2, then 3 plus root 2, 3 minus root 2 divided by this. So this one will cancel this. Since they are the same, it will cancel. So it will be left with only this. Then we use this one to multiply the top one. Then we get 2 times 3 plus root 2. That's what we are saying. Then we apply out our multiplication here. Now, 5 times 3, then 5 times negative root 2. So, still, it will be 15 times 5 root 2. Then negative root 2 times 3 is 6 times negative root 2. Yeah, you can go like terms and move on. Also good. Then the denominator, let's multiply by what here? This one is difference of 2 square. So I just use the difference of 2 square approach here. So 3 square plus root 2 all square. Okay? Or you can decide to do your multiplication. You are good to go. Therefore, this is what we get. And here we have root 2 here, root 2 here. So we can go like or we can go straight. So 15 minus 6 is what? The answer that we get. Then negative 5 root 2 minus negative 2 root 2. Under addition and subtraction, go and revise. Therefore, our final answer is 9 minus 7 root 2 out of 7. Okay? So 15 minus 6 is 9. Then negative 5 root 2 minus negative 2 root negative 2 root 2. So the root 2 will go. So that's all. That's why we got the negative 7 root 2. So this is our final answer. But we can still simplify. If we divide here, the 7 will cancel. Okay, but I can leave it like this. So this is the conjugate of said. Subscribe to Sneapelus for more videos. Please try this and give me the final answer under the comments. Okay.